Hey guys, welcome back to ILR Performance. We're going to do another video on re-sleeving cylinders. This one's going to be a lot faster than the last video. In this particular case, we're going to take one of these aftermarket TRX 250R cylinders that's already been sleeved. They come from LA Sleeve, already sleeved. This particular one's been punched out to a 360. And it's been run long enough and bored out enough that there's no more material left and no more pistons left to go bigger on the bore. So we're going to put a brand new sleeve back in it. We're going to change some of the porting while we're in there because this particular cylinder had a lot of JB weld in it to plug off some ports and to reroute some things. So we're going to take care of all that in the new sleeve so we don't have any JB weld in our cylinders in this cylinder when we put it back together. So as you can see, here's the old liner that we took out. It's decent shape. It was a pretty good job, well done. There's our blank LA Sleeve cylinder. We're going to pop that cylinder out of the wrapper. We're going to cut ports in it on the milling machine. I'll show you how we do that, and then we're going to drop it in the cylinder. Here's our blank LA Sleeve cylinder out of the wrapper. You can see it's got the same outside diameter as this one did. We special ordered it to that size. We're going to have to do some work on the flange here because the thickness from here to here is a little bit different. Plus you can see this one has an O-ring, so we're going to have to we'll thin this one down first. We'll cut the O-ring groove in it. Then we'll make a pattern off of that one. We're going to change some of the port timing a little bit and eliminate a couple of ports and move some things around. So I'll make a pattern of that one. We'll take that pattern, transfer it onto this cylinder, make our modifications, and we'll put it in the milling machine and machine it up. Now I've made a pattern off of the original cylinder, transferred it to paper. I want to change port timing on this motor a little bit, so I did that in the pattern. I changed the port timing and I moved some ports a little bit. Took the template, wrapped it around the blank steel sleeve, put the blue Dykem on there. So now you can see we have all of our ports laid out. Now we can take it over to the milling machine and we can mill it out. All right. We're set up in the milling machine now. You can see we're on the rotary table so that we can turn the cylinder around and come down and cut our ports. Nothing left to do except start cutting away. Here is our liner after we've finished it in the milling machine. We've cut all the ports, transfer ports, exhaust ports, boost ports. We have the intake in. You can see that I haven't cut the bottom of it yet. We'll do that after I put it in the aluminum, and I can put it back in the milling machine and cut it so it matches the cylinder. It's just as easy to do it that way, and I kind of prefer it. When I posted my last video on sleeving the 310 Kawasaki, I got a lot of comments back about how come I didn't just bore out the aluminum bigger and have it replated. Well, first and foremost, I like sleeved motors. I have really good luck with them. The durability is good. The reliability is great. But for these big board kits, you can see that we've punched this out so far. There's nothing left here. So something has to go back in here. You can see there's no spigot left. It's been bored out that far, and you really can't see up in there, but the wall between the water and the inside of the sleeve is less than 2 millimeters, It varies between about 1 1/4 and 1 3/4 millimeters in thickness, which is pretty thin. If I decided that I didn't want to put a steel sleeve in there and I did want it plated, I could build an aluminum sleeve. Just take a piece of aluminum tubing and cut it just like I did with the iron and put the aluminum sleeve in here. But by the time I got the aluminum sleeve in here and I got it bored out to the finish size, I'd have an aluminum sleeve that was only 2 millimeters thick, and I'd have less than 2 millimeters of water jacket in the top. So I'm running a motor that I'm trying to get close to 100 horsepower out of in an aluminum liner that's less than 4 millimeters thick. And there's just not enough strength there to do that reliably. So again, the centrifugally forged cast iron liners, they're really strong, they're flexible, they dissipate heat really well, and they allow me to go this big on a casting and still build a reliable motor. So next thing we're going to do is we're going to go ahead and put this in the freezer, get it cold. We're going to drop this in the oven, heat it up to 400 degrees. Then we're going to drop the liner in and get it set. Okay, cylinder's been in the oven for 45 minutes. The liner's been in the freezer for the same length of time. We're going to pop the cylinder out. We're going to drop the liner in and get everything lined up. All right, our liner's in, we're set. I'm gonna let it sit here for a minute or two, and then we're gonna take it over the press and go ahead and put pressure on it to keep the liner down while the cylinder is cooling off. All right, we've got the sleeve in the cylinder now. It's cooled off. It's about an hour after we drop the liner in. It's chucked up in the mandrel right now. I'm going to give you a little walk around. This mandrel picks up the center of the cylinder bore, dials in on the head on the lathe, the tail stock. And what we're going to do is we're going to machine the top surface, and then we're going to cut the O-ring groove in the liner. Then we're going to come back around to this side. We're going to cut the gasket surface, and then we're going to cut the liner off. The main reason that we surface both the top and the bottom in the lathe like this is so that we know that the gasket surface on the top and the gasket surface on the bottom are exactly perpendicular to the bore of the liner. And that way, when we put it in the boring bar, we know that everything is either parallel or 90 degrees. And so when we put it back on the bottom end, everything will be square. That helps improve performance of the motor. It also increases longevity because crooked bores in the cylinders or crooked gasket surfaces, they either don't seal well or they wear unevenly. So this will help make better power. So we'll go ahead and take a 5/1000 pass on this cylinder and see how square it is. This cylinder is definitely a long ways out of square. We put the liner back in the original bore The liner is parallel inside and outside, so this cylinder was a long ways out. Well, we made the first pass, took 5/1000ths off. There's still quite a bit of material that didn't clean up, and it's not perfectly square. So we're going to take another pass and make sure that it's good and square. Okay, that cleaned up real nice. Now we're going to go ahead and change the tool, and we're going to cut the O-ring groove. Okay, here's our cylinder. The new sleeve is installed. You can see we've trimmed it down to length, put the bevel in the inside, a little chamfer on the outside, but we still have to cut here, 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 and here, and then we have to put a little notch back here for the intake so that we match the original liner. But we now have a nice smooth gasket surface all the way around. You can see it cleaned up pretty good. On the top, we have the same thing. We have a good clean gasket surface all the way around. Nice cut. One of the things you will notice, or you may notice, between the original liner and the way that we do the liner is on this particular liner, the O-ring is in the liner. The entire width of the O-ring is in the liner. There's a lip on the outside, a lip on the inside. So the O-ring just seals between the lip of the steel liner and the head. One of the issues with these cylinders from day one, and it's not a big problem, it's something that occurs on almost every one of these, is that you will get water between the liner and the aluminum. And that's because the water is allowed to creep all the way up to here before it seals on the O-ring. That means that any of the water that comes up the water jacket can creep over. What we've done is we've moved the O-ring out to the outside edge of the liner, so the O-ring actually picks up the outside edge of the liner, but also the inside edge of the aluminum. So when we put our O-ring in here, and you'll see it later on, or you'll see it in the next video, when we put this motor together, that the O-ring is actually sealing clear out here to the aluminum, so that any of these water jackets that are full of water, as they warm up and cool off, if they weep into this area, they stop before they get to the cast iron liner. And what happens is you heat it up and you cool it off, and you heat it up and you cool it off, and little by little a small amount of antifreeze creeps in between those two surfaces. And this video is probably not good enough to really tell, but you can see the discoloration in this area in particular, where the water has gotten down in between the sleeve and the aluminum. And a tiny bit of water doesn't really hurt anything. The water dissipates heat just fine, but eventually the water slowly migrates down into the transfer port or into the intake port, and that actually causes water to be in your combustion chamber. The exhaust tends to be a little bit hotter, and it tends to boil the water out, and very little of it gets through there. But you can see that there's definitely been moisture in between the liner and the aluminum. So this modification that we do by moving the O-ring out and sealing between surfaces seals up that gap in between, and we no longer have water intrusion in between the liner and the aluminum casting. It is a perfect time to do it right now. We end up using an O-ring, a head gasket O-ring for a big Rotax, Austrian built motor. So it's a readily available motor from Sea-Doo, and so it's pretty easy to get the O-ring, readily available item. We use the standard O-ring, the standard LA sleeve O-ring on the outside, and we get a really good seal. So now we have this top and bottom. We got the liner installed. Got a really good port match. It's really hard to see on a camera, but our port match is pretty good. Our transfer ports line up real good. We got good boost ports. We got good exhaust ports. So the next thing we're going to do is we're going to cut the lower part of the liner, and then we're going to put it in the boring bar and bore it up to size. Okay, all done with the machine work. The notch is cut out here. Transfer slots are cut out. Obviously there's a bit of mismatch yet to go, so next thing it goes over to the porting bench and we'll do a full port job on it. Then we'll sandblast the cylinder. Once those two things are done, we'll finish hone it to size, and this thing's ready to bolt onto the bottom end. Here is our cylinder. You can see that I've glass beaded it, clean it all up, get rid of all that old paint. The machine work is all done. We've matched the liner to all the ports, done a bit of port work in there. Made sure we had good intake boost ports, everything fits real nice. This cylinder was ported before we took the old sleeve out, so it was a little bit easier to match back to the original porting and get everything cleaned up nice. The cylinder is now machined to the nominal bore size so that we can do the fit up on the 250R bottom end. We're going to check things like clearance for the crankshaft, the sleeve to the bore in the case, as well as making sure we have the right compression ratio and all our port timing is correct. But we're going to put that in a separate video, so you can look for that. Anyway, thanks for watching the video. If you like the video, please subscribe to my channel. It helps me make more videos. And if you have comments, go ahead and put them in the comments box, or you can send me comments and questions on Facebook. And we'll talk to you later. Thanks for watching. Bye.